Imagine opening a pull request written entirely by an AI agent. The tests are green. A second AI says the change is safe. Do you still need a human to read every line before it can be merged? This paper gives a provocative answer. For routine changes, no. It doesn't prove that an AI-only pipeline is already safe everywhere. But it argues that mandatory human review is becoming the wrong default. So, let us examine the proposed workflow, the evidence behind it, and the cases where human judgment still cannot be removed. The argument begins with a simple capacity problem. Human attention doesn't scale. Developers in large organizations may spend 10 to 15% of their working time reviewing other developers' code. And feedback in a pull request can take more than 24 hours. That was already expensive before code agents. Now imagine that every developer can generate several changes in the time it once took to write one. The number of pull requests rises, but the number of qualified reviewers does not. The review queue becomes the new bottleneck. The paper is not saying that review has no value. It's asking whether every routine change should still wait for scarce human attention. There is also a quality problem. A human approval can remain in the workflow even when the real assurance behind it has weakened. AI-generated code often looks polished, it's well formatted, internally looks consistent, and may already pass the existing tests, but that can make a large diff harder, not easy to review. Finding a subtle semantic error may require understanding the repository, tracing data across files, and checking assumptions that are not visible in the diff. Under time pressure, the review can become the code looks reasonable, the test pass, approve. This is the paper's argument. It identifies a real danger, keeping the human checkbox while turning the review itself into a rubber stamp. The proposed replacement is not blind trust in one AI approval. It's a shift from person-based approval to evidence-based routing. In the old model, automated tests, security scans, and CI may all pass, but the change still wait a person to click approve. In the new model, the system collects an evidence bundle, test results, security findings, style checks, an independent review report, uncertainty estimates, and a risk classification. That bundle determines the next step. A narrow, low-risk change can merge automatically. A failed check returns to authoring agent. The key idea is that human intention becomes an escalation path, not a mandatory checkpoint for every diff. Here is the complete workflow. First, AI coding agent receives a task and produces a change. Then, one or more independent reviewer agents inspect it. They should not simply repeat the first agent's reasoning. They examine the diff, repository context, test, security checks, and project rules. Next comes the risk gate. It combines the evidence with predefined thresholds. There are three possible outcomes. If the reviewers find a problem, the change returns to the authoring agent for revision. If the change is low risk and every required check passes, it can be merged automatically. If confidence is low, the change affects a regulated area or the architectural impact is significant, it's rotated to a human. This is more explicit than the usual looks good to me, but its safety depends entirely on the quality of the evidence and the routing rules. Consider dependency update, because this is the kind of routine task where the proposal is easiest to understand. The authoring agent changes the package version and updates any affected code. An independent reviewer inspects the diff and checks compatibility. Continuous integration pipeline runs test suites and automated security scans. Now the risk gate evaluates the result. If a vulnerability, failing test, or compatibility issue appears, the change goes back to the authoring agent. The agent revises it and the checks run again. If the update is narrow, reversible, and all evidence passes, it can auto-merge. But if the package affects a critical interface, changes an architectural contract, or the reviewer is uncertain, a human makes the decision. The threshold reduce arbitrary decisions. They do not guarantee that the risk classification is correct. Now we reach the most important critical question. Does the evidence actually prove that this workflow is safe? Paper point to the rapid improvement of coding agents on SWE bench. Performance move from roughly 1.7% in early systems to about 12.5% with SWE agent and above 70% for leading agents by late 2025. That is impressive evidence that agents are becoming much better at repository level software tasks. Other studies also show that language models can generate useful review comments and operate tools. But there is an inference gap. Solving benchmark issues is not the same as safely approving production changes. The paper doesn't present a controlled deployment, where an agent-only view pipeline is compared with human review. So, the evidence supports stronger agents. The proposed replacement of the gate remains an argument that still needs direct testing. The author argues that agents can cover every major purpose of code review. For defects, it can inspect repository context, execute tests, and repair failures. For standards, they can combine traditional linters with semantic checks, such as naming and API usage. Specialized agents can search for security weaknesses. Agents can also generate summaries, explanation, and documentation, giving the team a structured record of what changed and why. But this is where the technical definition of review is become too narrow. Documentation is not the same as mentoring. A generated summary doesn't fully transfer tacit knowledge, team history, or engineering culture. Agents may replace many review activities. They do not automatically replace human relationship that grew around those activities. The workflow also introduces several serious failure modes. The first is false confidence. A reviewer agent may approve a change without realizing that it missed something. A partial mitigation is calibrated uncertainty. The agent must be allowed to say, I don't know, instead of always returning a confidence answer. The second is shared blind spots. If the author and reviewer agent use closely related models, they may repeat the same mistake. Different model families, different prompts, an ensemble review can reduce this risk, but they do not eliminate it. Architecture, regulation, ethics, and legal accountability still require human governance. These decisions depend on long-term design goals, organizational values, and named responsibility. And one problem remains genuinely unsolved: prompt injection inside the code being reviewed. A malicious comment or string could try to manipulate reviewer agent. A practical recommendation is to treat embedded instruction as hostile, restrict the agent's permissions, and escalate suspicious changes to a human. What should do a real development team with this idea? Don't jump directly to full autonomous merging. Start with agent comments, while humans still approve every change. Next, allow the agent to block a merge when it finds a clear problem. Then introduce auto-merge only for a narrow class of routine, reversible, well-tested changes, such as selected dependency updates or simple refactors. Expand that class gradually, using audit logs, incident data, false negative analysis, and rollback metrics. High-risk, architectural, regulated, and ethically sensitive changes should still continue to go to humans. That is the useful version of the paper's thesis. It's not the end of the human judgment, and it's not proof that AI should control every repository today. It is the end of treating every div as equally risky and making every change waiting for the same human checkbox. It was a quick overview of this article, and I hope it will be useful.